and good day. Now, this time I would like to discuss on how to integrate a function, okay, in the form of 1 over something. Okay, as you can see here, 1 over something, whereby the something is linear function. Okay, in the form of ax plus b lah. Okay, if we have this kind of form, a fraction, okay, the integration will be the natural log of ax plus b of the linear function divides by the, I'm sorry, I used the wrong symbol, the differentiation of ax plus b plus c lah at the end, of course. Okay, now, okay, so just copy paste the content of the bracket. So how we are going to guess whether a fraction will be turned into ln? Okay, it's easy. The first thing that you can spot is it must be 1 over something. That's the first condition. The second condition is 1 over something. The power of that something must be 1. And also the inside here must be linear. Okay, so if these 3 conditions are met, it will be most likely the function will be integrate and become ln. Okay, one example that a fraction doesn't become ln when we integrate it is like this: 1 over 3x squared minus 2. Okay, so what's the first condition I shared? It must be 1 over. So this one, correct, 1 over. Now, everything is power 1, right? But the problem is the content of everything is not power 1. It must be linear. But what we have is quadratic. So cannot lah. Okay, so just leave it be. Okay, padam all. We continue with the first example. As usual, you can pause the video to digest the formula above. Okay, so let's go for question number 1. Now, so we spot 1 over all something power 1, the x also power 1. Okay, so it's linear. So we can simply ln all the bracket, copy paste, and then we divide by the differentiation of the bracket itself. Okay, and then plus c. That is not c. C. Okay. Now, so it's ln 3x minus 2 divides. Okay, differentiation of 3x minus 2 is simply 3. Okay, plus c. Take note that this thing is not equals to ln 3x minus 2 over 3. Okay, this is wrong. Okay, so I showed you already, it is wrong because this ln is one whole lot. The division by 3 means that we are dividing the natural log of the whole function, linear function, by 3. So we can put over 3 as 1 over 3 in front of the ln. Okay, so good to go. We go to the second one. Now, what's the problem with this? The problem is with this 2. It's supposed to be 1 over something. So how to how to get 1 over something is that we factorize the 2 and put outside, because as we know, 2 is simply a constant. Okay, 2 multiplied by 1 is 2. So we can put 2 outside. 2 outside, 1 over. See? Nampak already. Okay, so we get 1. Okay, 1 over something. This over, this is something. All something here. Okay, I rewrite. 4 minus 5x. This all something power 1, right? The power of x also power 1. So most likely will turn into ln. Okay, so 2 bracket ln what? Everything inside the tiny bracket there, 4 minus 5x, divide by the differentiation of the whole thing. Okay, the bracket itself lah, and then plus c. Okay, so So 2, you see the differentiation is 4 minus 5x is minus 5. So minus 5 here. Ln 4 minus 5x plus c. So that's it for the second one. Let's move on to the third one. Okay. Now, just now we had example of a constant on top of the fraction. Same goes with this one. Minus 6. Minus 6 is constant. We can only do this method, okay, bringing the stuff on top outside only if it's a constant. If it's a variable, if there's x over there, we cannot do anything. We have to do some other method. So bring minus 6 outside. 1 over, we can see already 1 over. So most likely the whole thing will turn into ln. Let's see. 1 over something. Good. The something all power 1. The content of the bracket is power 1. Perfect. We can continue. So minus 6 bracket ln 2x minus 1 divides by the differentiation of 2x minus 1, the bracket, plus c at the back. Okay. Minus 6 over 2 ln 2x minus 1. Where did I get the 2? I got the 2 from the differentiation of 2x minus 1. So 6 2 we divide, become 3. So minus 3 ln 2x minus 1 plus c. Okay, good. Let's move on to the last example. Only 3 Why only 3? Oh well. I think that's all. Thank you for your time and attention.